Okay, so yesterday by the way, today is October 21st, 2016. We talked about the triangle angle sum theorem and the fact that the angles of a triangle add up to 180 degrees. Today we're going to talk about exterior angles of triangles. So an exterior angle of any polygon, doesn't have to be a triangle specifically, is formed by two criteria. It's formed by a side and an extension of a side. So if I take this side of the triangle and I extend it out, that's going to be my extension. And then here is an actual side of the triangle, and the angle formed in between them, that is my exterior angle. So it doesn't necessarily just mean an angle outside the triangle. It has to be specifically formed by a side and an extension of a side. And in a triangle, specifically, when you have an exterior angle, like we had exterior angle 1, we have two other angles in the triangle that are related to this triangle. And the name of those angles is the remote interior angles. And so that word remote is going to be key, because not only do they have to be interior, not only do they have to be inside the triangle, but the word remote we know means far away from everything else. So in this case it has to be far away from angle 1. So like I can't have an angle 4 right there and call it remote interior. Angle 4 is interior, it's inside the triangle, but it's definitely not far away from angle 1. It would be adjacent to angle 1. So here we go, example 1. Which of the numbered angles at right are exterior angles? We see that angle 8, angle 2, and angle 3 are all exterior angles. Some of you right now are asking, now why is 4 not an exterior angle, Miss Benton? Well, if you look at it, angle 4 is made up of two extensions of the sides. It's not at all formed by a side of the triangle itself. So angle 4 doesn't meet the criteria for an exterior angle according to the definition. Alright, so name the remote interior angles for each. So for angle 8, if we're talking about angle 8, the angles that would be inside the triangle and far away from 8 would be 5 and 7. For angle 2, if you're talking about inside the triangle and far away from 2, it looks like you're looking at 6 and 7. And if you're looking at angle 3, again, it's going to be 6 and 7. And then the last question is, how are angles 2 and 3 related? Well, they are vertical angles. That's all they're looking for. It's for you to say they're vertical angles, or you could even say angle 2 is congruent to angle 3 by vertical angles. Alright, so here's our investigation. The exterior angle and remote interior angle, what's their relationship? It says find the measure of the exterior angles. So using the fact that I know that all the angles in this triangle are going to add up to 180 degrees, I'm going to say 55 plus 33 adds up to 88, and then I'm going to subtract that 180 minus 88, and I get 92. So I know this angle right there is 92. And then I know that 1 and 92 are a linear pair, so 180 minus 92, angle 1 is going to be 88 degrees. Okay, let's do the same thing for our second example over here at the right. Okay, again, all the angles in the triangle add up to be 180 degrees. So 27 plus 76, it's going to be 103. So then 180 minus 103, that's going to give us 77 degrees. So we know that this angle is 77. then we can use a linear pair. 180 minus that 77 is going to be 103. So, what conjecture can you make about the relationship of the exterior and remote interior angles? Well, I don't know if you noticed, but when we added up the interior angles, we got 103, and then we subtracted that from 180 and got 77, then subtracted that from 180 and got 103. If we had just gone with adding these up, we had our answer right there. Same thing over here, 55 plus 33, that was 88. Look, our answer was 88. So the shortcut is here, friends, that the sum of the remote interior angles equals the exterior angle measure. Alright, given that there are 180 degrees in a triangle and 180 degrees in a straight line, why does this make sense? Well, because we were saying 180 degrees for the triangle minus, we'll call it x, gives us 180 minus x. But then we were coming over here for the linear pair and we were saying 180 for the linear pair minus 180 minus x, right? And these 180s were canceling out, and so we were having minus a negative x, or in other words, x. So that's why that works. Alright, so the triangle exterior angle theorem says just what we just figured out in our investigation, that the exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So if this is angle 1, this is angle 2, angle 3, then angle 1 equals angle 2 plus angle 3. Okay, so let's try this out on some examples. Example 2. So we have 90 degrees and 46. Those are our remote interior angles. So it should be that 90 plus 46 adds up to be our exterior angle, angle 3. So this would be 123. Let's look at a little bit of algebra here on part B. Same idea though. This is a remote interior angle. This is a remote interior angle. So 2x minus 11 plus 2x plus 27 adds up to the outside angle, the exterior angle, 100. So 2x and 2x is 4x. Negative 11 and 27 gives us 16. Subtract 16 from both sides. Yeah. So that's going to be 90, 84. So 40, I'm sorry, 21. When I divide 4 into 84. Alright, you can pause the video at this point and try the U-try. I'll meet you on the other side. Alright, so this U-try was a little trickier because the angle you did not know was on the inside this time. So perhaps you set up an equation and said 32 plus angle 2 equals 120 degrees. And then you subtracted that 32 degrees from both sides. And angle 2 would be 88. And you can watch the next video for the exterior angle inequality theorem.